Hello, everyone. Welcome to our very first VLINGO platform webinar. This is Reactive DDD with the VLINGO platform. May I get a show of hands of everyone who's able to attend today? Do you hear me fine? Okay, I'm going to assume that everybody can hear me right now. So I'm going to begin. Reactive DDD with the VLINGO platform. There's quite a bit of information to discuss on this subject. So what I'm going to do is I'm going to talk about the definitions of each of these parts of the presentation. What is reactive? What is domain-driven design? And how does the VLINGO platform fit into this? And I do have quite a bit of material, so I'm going to be going through this rather rapidly. Many of you probably know me for my DDD work in implementing domain-driven design book and domain-driven design distilled. Also, though, I've spent quite a bit of time implementing the VLINGO platform. And the VLINGO platform is currently available in production mode. We're currently at version 1.2.7, and there's also a .NET version that's being implemented, and that one is a bit behind, but it's making great progress. It's right around 0.7.0, something like that right now. So what is reactive? Reactive is largely message-driven, and message-driven accommodates some other characteristics of reactive. This is to facilitate elasticity, so you have dynamic scalability, and you also have resilience, which is provided through, in the actor model at least, through actor supervision. And reactive is responsive, and one of the big reasons that it's responsive is because it is not blocking threads. So anytime that an actor is essentially waiting for something to happen, then it's not blocking a thread. Instead, the thread that it was using before it needed to wait on some sort of response is being used by another actor at this moment. So we'll get into these more as we move through the presentation. A long time ago, probably back in the year 1985, I was an independent contractor, and I had the opportunity to go hear Grace Hopper speak, and she gave a very inspirational talk, and in part of her discussion, she handed out a little wire like that you might find at the time in a telephone line or something like that. And this little wire represented, in terms of standard measurement, it was about maybe 10 inches or 12 inches long, which I'm not sure what that exactly is in centimeters, but it's let's say it's maybe 6 or 7 centimeters, something like that. And what this wire was to demonstrate is this was at the time, the representing the speed that light could travel through a wire and of that length. And Admiral Grace Hopper was noting that we didn't want to waste nanoseconds. So her message was, be very careful about being wasteful with computer processing power. Well, that was a very big deal at the time. If you think back, if many of you were even born or in school at the time and around that year, computer processing power was quite limited at the time. Another thing that you've probably heard about optimization is this supposed quote from Donald Knuth: premature optimization is the root of all evil. And I like to point out that although Donald Knuth did say this, this statement is not a complete statement. It's not all of what Donald Knuth said. He actually said, we should forget about small inefficiencies, say about 97% of the time. Premature optimization is the root of all evil. Yet, we should not pass up our opportunities in that critical 3%. So you have to ask yourself, what part of the software that you're using today is not efficient? I would say it probably even goes beyond, well beyond 3%, but let's take this in the context in which he said it. There was some amount of optimization that was worth pursuing, and we should not pass those up. So I think this should be an axiom in software architecture, software development. Blocking is not a small inefficiency. So we should look out for any opportunities to use our current hardware the way that it was meant to be used. Donald Knuth also said people who are more than casually interested in computers should have at least some idea of what the underlying hardware is like. Otherwise, the programs they write will be pretty weird. I love that statement. And one of the things we should know about the computers that we run our software on, the hardware, is that it is currently multi-core. And that is the way that we are able to speed up our software, is by using multiple cores, because the individual cores themselves, as in the thread, the hardware threads, are not able to process much faster than they were, let's say, even 15 years ago because of something that happened. Moore's law predicted that, or we might even call it Moore's prediction, predicted that processor speeds would continue to grow exponentially over the time of, at all times in the future. But what actually happened is in 2003, the processor speeds fell off. Okay? And what we started to get instead of faster processors was more processors. And that started with hyperthreading on a single CPU, and then extended to hyperthreading with multiple cores. So cores matter. The more cores that we have, the faster our software could be, but each core itself is not much faster than it used to be. Currently, it takes roughly 9 years to see the same sort of speed increase that we saw in about 18 months before the year 2003. So I would say that it's wrong to always conclude that all optimization is the root of all evil. It simply is not true. And the proper use of cores today is extremely important. That's because objects block. When a client object invokes a method on a server object, and these are objects in the same, let's say, Java virtual machine, then the client is blocked until the server has completed its tasks, and whatever may happen underneath the server object, this is also blocking the server, and so there's a lot of software that's just blocking. And when we finally hit the database, quite likely the thread that the client is blocking on and the server is blocking on is now blocking on I/O over the network and back for some sort of database request. Well, maybe you've also thought that threading is easy. If threading is easy, then why not just write our own thread management? The thing is, threading is hard, and just when you think you have threading figured out, you probably don't. There are some people who understand Java threading or even .NET task execution as in thread task, and they may understand this quite well, except that there are various volatilities in doing so. Different threads can block or try to reach some sort of entity, some sort of object simultaneously. There are all kinds of opportunities to block, and also race conditions, and even a thread's visibility of state that changed in a different object through a different thread. So there are all kinds of reasons why writing your own thread management is quite complex. So when you consider these two what seem to be minor attributes of reactive, the small print, so to speak, is maintainable and extensible. So when you are doing reactive programming, think in terms of using tools that make your software maintainable and extensible. So what is this? The actor model is what I refer to as objects done right. When a client requests some sort of service from a server object, again in the same Java VM, this is a non-blocking asynchronous operation because it's done through asynchronous messaging. In fact, with the VLINGO platform, actor message sending looks just like a method invocation, and yet underneath the method invocation is actually a message send. And this aligns with what Alan Kay said about the original idea of object-oriented, and that the big idea is messaging. So the objects and the messages sent between them are really the communication and collaboration that we should be focused on, because this is actually the kind of conversations that we can have with the business. They don't understand the inside of these objects, and they shouldn't have to. And so the actor model with message sending really focuses well on or works well with domain-driven design. What is DDD? Well, let's give this definition very briefly. It's what I would consider communication, learning, language, and context. So we communicate with people, we communicate with objects using the same kinds of communication that we have with people, and we learn from that communication that we have from people, and we codify that in our source, and that is reflected as a language, as a domain language, or a spoken language that is also a software language, and that language has a specific context within a bounded context. And this really is helpful to use when you consider Conway's law. In organizations which design systems, these systems are constrained to produce designs which are copies of the communication structures of these organizations. So the way that we communicate within our teams, within our departments, within our organizations, whatever our structure is within that organization is going to be reflected in our software. So if this represents the developers on your team or in your organization, and if this represents the business experts within your organization, then you simply are not going to fare well under the consequences of Conway's law. So we have a choice, but unfortunately, most organizations today don't use that choice well, and they don't communicate well, and so the software that they produce is a reflection of the poor communication that they have within their organization. Domain-driven design attempts to help you to improve that quite a bit and sort of fix that problem that exists within organizations. So DDD, in being about language in a context, means that there will be multiple languages with multiple contexts, and that these multiple contexts will have to communicate with one another, and this is called context mapping. And there are various mapping relationships to context mapping. Messaging is how we communicate often between contexts. These messages are intentions, such as commands, and facts, such as domain events. But within a bounded context, how can this be done? How can the communication work? Well, I'm going to give some definitions of what VLINGO is. VLINGO is a DDD-friendly reactive platform. Here you see a bounded context represented as a rate service. This rate service has a ubiquitous language within this boundary, and the objects, the pale yellow objects that you see in the middle of the diagram here represent the objects of the ubiquitous language. And they would, of course, be exchanging messages because this is VLINGO, and VLINGO is a reactive platform that has underwriting everything asynchronous message sending. As you see here, VLINGO has a concept of a world. And so the top level abstraction of VLINGO is that everything runs within a world, and within a world, actors run on a stage or within a stage. And there can be multiple stages. There is a default stage that's always created when the world is created, but potentially you may also want to use other stages for various reasons. And one of those reasons is, for example, when we run our compute grid through VLINGO Lattice, which you'll see in a few moments, we have a stage that is specifically for the compute grid that is run on every single node within a cluster. VLINGO also supports domain-driven design in that you will have multiple languages and multiple contexts, and so we support directory, a VLINGO directory, which is for registration and discovery. This is really at the heart of a microservices architecture because two different services with two different ubiquitous languages must still communicate with each other. And this shows the communication between two services using HTTP. So the rate service can know about the risk service through a constant stream of information being fed to it but through a subscription to the directory service, and therefore basically at all times within a few milliseconds the rate service will know the current availability of the risk service, and it can use HTTP to communicate using REST, for example. Within the rate service and within the world within a stage, for example, we have actors. These are represented by the objects marked with E, and the E objects are entities. This is just a very high abstraction. They represent entities, and entities may persist their state and any sources or what we call sources, as in domain events, into an object store that has a journal. It can persist those into just a journal, as in an event sourcing journal, or the entity can persist its state into a state store, which is a key value store, and this also has a backing journal. And these additional backing journals mean that even entire state persistence, such as an object or a blob state in a key value store, can still persist atomically domain events along with their state. The storage engines that we support so far are DynamoDB, Apache Geode, and various stores that are available under JDBC. This is Postgres, MySQL, or MySQL, MariaDB, Yugabyte, and HSQLDB. But really, we have the ability to support any kind of storage engine that is supported by or that has a JDBC driver. Soon we'll be releasing fast scalable both state, object, and journal stores, and you'll hear some announcements about that soon. So VLINGO supports what are called object entities. This is an abstract base class that is an actor. A stateful entity is also an abstract base class that is an actor, and you get persistence basically for free through these, but these are focused on DDD modeling. So this is where your entities or aggregates would be modeled inside one of these objects. We also support a sourced object, so event sourced and command sourced, because depending on your viewpoint, you may want to source your state using commands rather than events. But in any event, DDD modeling is done also inside one of these kinds of entities. Well, one reason that you might want to have a command-sourced entity is if it's a process. So typically processes are known for reacting to events and emitting commands that say this is the next thing to do. And we have support for processes or sagas that doesn't matter if you want to use object persistence or stateful key value store persistence or even command sourced and even event sourced. You can mix these in a process. Then we have an answer for that as well. And VLINGO is, of course, since it is an event-driven, supports event-driven architecture, you see that initial client making an HTTP request, but after that request is made, we have a resource that's marked by the R actor, and the R actor is an HTTP resource or an endpoint that receives an HTTP request. It directly delegates to an entity in the domain model. That entity is marked with E, and the entity can automatically, through the base classes, persist to a journal, persist to a state store, object store, whatever. And these can include, of course, the orange objects, which are domain events. After a domain event is stored, it can be streamed out of the storage, and the X actor there represents a feed to an exchange topic. And this could be any kind of exchange or topic messaging mechanism. Could be Kafka, could be RabbitMQ, could be SNS, SQS, any number of kinds of queuing mechanisms. And a subscriber in the rate service, then marked with an S, receives each of those events and can translate those events into commands that are then executed on the entity marked with an E there in the rate service. So notice that a translation takes place. VLINGO actually helps you to make that translation from an exchange to an internal type, or when you are feeding the exchange, the event that goes on the exchange can actually go onto the exchange as a type that is foreign to the RISC service. So that translation can be done on either side or both sides of the exchange. VLINGO also is a compute grid, so we have our own cluster, the VLINGO cluster, and the VLINGO cluster is used by VLINGO Lattice to produce inter-cluster actor messaging, so messaging between actors that live on grid nodes or nodes across the cluster, and this represents a reactive compute grid. So any actor within the grid can send a message to any other actor not in the grid, and actors that are in the grid can also send messages to actors not in the grid that are local to it on the same node. And we also support a boot kind of mechanism, which is a quick start for learning to use VLINGO very quickly, and it's backed by a micro framework. You've probably heard of Micronaut by now. So although VLINGO does not require the use of Micronaut, so any of the components that you just previously were introduced to can be run without Zoom and can therefore be run without Micronaut, but we are providing Zoom as a convenience, as a quick start for anyone who wants to be able to just basically boot up the VLINGO platform with any defaults that we are reasonable defaults, and you can start implementing, for example, REST endpoints and aggregates or entities and so forth very quickly. So let's talk about one part of VLINGO that I haven't yet introduced you to, and that's VLINGO Streams. VLINGO Streams is just that. It's like a stream of water that, as a stream of water passes you, the water that passed you in the stream is now gone, and the water still upstream that will soon pass could still be consumed by you. So a stream or streaming is a way to handle data that passes by in streams, especially live data whose volume is not predetermined, so we don't really know, for example, how many domain events will ever be associated with a single bounded context. We don't really know, but as those facts continue to be recorded in a journal, then those facts can be basically streamed out of the journal and made available to consumers through the stream. And asynchrony is very important to this to take care of some of the special considerations. For example, one of the challenges that we face is, what if the source of data that is being streamed is coming at you quite rapidly? And as it comes to you quite rapidly, and you are the sink or the receiver of that stream, maybe the water starts to, or the stream of data basically starts piling up on you, and you become overwhelmed. So in order to avoid that, the Reactive Streams specification says that there should be a publisher, that there should be a subscriber, and a subscriber will be given a subscription by the publisher, and that you can have a combination of both a publisher and a subscriber, where one half of the processor that you see here is a subscriber, so it's listening to upstream data and that is streaming toward it, so it's a subscriber, and then it probably makes some sort of data transformation in the middle here using one of our VLINGO Streams operators, and the operator could map or filter or something like that, and then it's the responsibility of the processor that after that data is transformed in some way or translated, then it is sent out the other side, which is a publisher. So you have an incoming subscription and an outgoing publisher after some sort of data transformation. And this can create what is effectively the pipes and filters architecture, where every single one of the filters is actually a processor, so it's filtering in some way or modifying the data before it passes it through the pipe to the next filter. So one of the more important things about the Reactive Streams specification is back pressure. So it's not just pub sub, but it's pub sub with back pressure, meaning that we are purposely concerned with not overwhelming a subscriber. So this works by the publisher actually pulling from a source, and it will only pull up to n elements, and those n elements are defined by the subscriber, which says, I want to receive only n elements at a given time. And so the publisher will pull the source for those n objects or elements, and those n elements will be pushed to the subscriber, which will then push those to a sink. And so the source is the source of the elements, and the sink is the ultimate receiver of those elements. But notice how the back pressure is supported, and the subscriber can say, well, that's still too many elements at one time. I want to back those off. So it can request n minus something, and or n represents m minus some amount, or it can say I can handle more elements at any given time, and so it can request n plus a number of elements, and so it can fluctuate or gauge what the throttling will be like, either back throttle or forward throttle on the amount of information it can receive. And you can see that a processor can do the same thing. The processor in the middle there is both a subscriber and a publisher. So it's subscribing to a publisher at the left. It can control its own back pressure, and then subscribers to the processor can also maintain their own back pressure. And so this is how the pipes and filters architecture is achieved. How are streams used? Well, you can use streams in many different ways. You can stream over simple collections or iterables that are used in your model, your bounded context. You can stream on databases. You can stream on HTTP. You can stream on sockets. You can stream on a message bus, queue topic exchange, many different ways that you can stream, and we continue to add new kinds of streaming support to VLINGO. One of the most important questions, though, is as information is streaming across bounded contexts, what do we do about the contract of the objects that are streaming, such as what if we're streaming commands from the downstream context to the upstream context? Those are the objects that are blue. And what about the contract between the upstream and the downstream that a certain kind of event or set of events will be provided? And even as a result of a query, a document such as the white object that's coming back from the upstream bounded context also needs a contract about what can the consumer assume is available within that query result or document. So architects and developers love streaming, but when you think about a CIO or anyone who's responsible for the bigger picture of this, maybe even enterprise governance, you have to ask the question, everybody's busy, everybody's trying to do their best, but this CIO is wondering, where are the dependencies in all of this event-driven architecture, or for that matter, an extreme message-driven architecture? Who's producing what, and where are the dependencies on those elements? So we have to think in terms of the DDD published language, context mapping, and this is where we establish a contract between bounded contexts where this underwriting context, which is upstream, is producing a policy issued event among other kinds of events, and this is part of its published language that downstream consumers can count on this policy looking, having a certain structure, a certain data payload within it, and so this can be published as a contract between bounded contexts. This contract can also include what if that policy issued event didn't contain enough information for a downstream to perform some operation. Well, that downstream context can query back on the underwriting context, and an issue policy data document can be given back to the subscribing bounded context which can be used for a single operation. This is while it's part of the open host service, the issued policy data is also part of the underwriting published language. So to deal with that, VLINGO introduces what's called a schema registry. We have a product known as VLINGO Schemata, and Schemata is responsible for maintaining a registry for any number of bounded contexts within an organization and within business units within an organization. And this is what enables different bounded contexts to have a reliable exchange on the schemas between, or the objects between bounded contexts. And also we track those who are dependent on those schemas, so we also know who depends on those. And there are a lot of different use cases that are available with a schema registry that we support. So currently our schema registry has this structure. At the top level, you can define any number of organizations. Under an organization are any number of business units, and these can all have descriptive names, so you don't have to think in terms of a one-word organization or a one-word unit or even a one-word context. So under a unit can be various contexts, and this represents a microservice or a bounded context. And within that, you can define command schemas, data schemas. Data schemas are basically any kind of abstract data that's simply data types that can be included with commands or events, documents, and so forth. So, and then we support documents, which are generally what is exchanged across as query results. And we support events, so schemas for domain events, but also notice that you can even define the envelopes that will go around each of these schema types as they're being passed between contexts. This is an example of a set of schemas that belong to the company, the organization done by me. It's within the unit, the business unit, peer-to-peer business or peer-to-peer economy. And this is the matching context, and we're looking at specifically the events within the matching context. And notice that we support semantic versioning. Any schema, such as proposal submitted event, any two schemas that hold the same major version must be compatible with each other. So for example, 1.0.0 was the original. When 1.1.0 is created, it must be backward compatible. And VLINGO Schemata has compatibility checks, just like a compiler. Whenever the two versions, 1.1.0 is compared to 1.0.0, we will refuse to permit 1.1.0 to enter, to be pushed into the schema registry if it is not backward compatible with 1.0.0. However, since the major version changes on 2.0.0, this can be a breaking change. It doesn't mean that you necessarily have to have breaking changes, but sometimes this might be actually a requirement of your business. So VLINGO Schemata also has command line tools that currently work through Maven, and of course anything that supports the Maven plugin architecture. And so you can request to push your events or any kind of schema into a schema registry, or you can request to pull any kind of schema based on version number from other schemas. And this is how you cherry pick, because you actually can request a certain kind of source. For example, we're going to assume that when you ask for schema published version 0.0.1, that is going to come back as a Java-based schema. But you can exchange Java-based events with a context that is implemented in .NET or Ruby or Rust or any thing that can deserialize whatever your wire protocol is. And so the schema registry can produce schema contracts as classes, for example, for any language that we support. An example of streaming here is a simple mapper that's going to map from a string to an integer. And so we have the mapper defined as an operator at the top. This is an operator of a map with that takes a string from the stream, and it translates that string to an integer. And we have a results array list, and then we have an array list of the strings 1, 2, 3, 4, 5, 6, and 7, 8, 9. And for each of those strings with digits in them, we're going to use the mapper to perform a mapping, and that mapping will go from, it will use the mapper at the top and then give the final number, the integer, as the argument to the lambda, which is the consumer on the right-hand side, and that consumer will put each of those numbers or integers into the results collection. Another example is a filter. So this is where the operator is a filter with filtering out any strings that do not have the substring of the digit 1 in it. And you see the same kind of result, but this is a string results list, and we're going to create a list of ABC, 321, and so forth. And so as we filter over those, notice that we have a possible match on digit 1, but we're still going to ask the filter to filter on whether or not this is actually contains a digit 1, which will use the filter, and then it will give each match to the consumer lambda that you see at last there, and that results will then be put into the string array. And here's one that everybody loves. This is where we have a journal, so an event journal, for example, full of domain events, and we want to stream all of those events, and so we get a stream of those events, and we can tell the stream to flow into a consumer sync, and the consumer sync then does some proposal performance analysis, and this is where our proposal event types are being analyzed, and then some sort of performance result is then sent to another filter downstream at the very end. So I've enjoyed providing this overview of VLINGO and even some source code related to VLINGO streams. I have some upcoming workshops that are available, one in Munich at the end of, or I'm sorry, one in Berlin at the end of March. This is our new monolith to microservices workshop that uses domain-driven design and various techniques to support the conversion from monolith to microservices. And I also have another event coming up soon in Hamburg, Germany, and this will be an IDDD workshop. Both of these can be found at idddworkshop.com, and there's a discount code available for everyone for both of those events, and the code is named VLINGO, of course. So feel free to register for that with the discount code.